So let's look at worked example 14.1 and looking at this compound here, give the systematic name of the following alcohol and classify it as primary, secondary, or tertiary. So pause the video for a few minutes to figure this name out and classify the alcohol. Okay, so the first step is to determine the longest carbon chain that contains the alcohol. And you can either start with the methyl on the top of this chain or the bottom, and you'll get 5 carbons in the carbon chain that contains the hydroxyl, so it's a pentanol. Then we want to number the carbons so the hydroxyl gets the smallest number possible, and when we do that, the methyl is also on the 2 carbon. So the name of this is 2-methyl-2-pentanol. If you got that right, give yourself a pat on the back. And then this is a tertiary alcohol because the carbon that's bonded to the hydroxyl group has 3 other carbon groups bonded to it. No hydrogens bonded to that carbon. All right, let's look at another example. Let's look at worked example 14.2, and it tells us to draw the structures. So let's just draw the line structures of 2,3-dimethyl-2-butanol and 3-ethylcyclopentanol, and then classify each as primary, secondary, or tertiary. So go ahead and pause the video. So your line structure may look a little bit different than this right here, but as long as the same connectivity exists, then you're going to be right. So we have a, 2-butanol. So right here is our 2-butanol. We can look at it as sort of this bolt structure or as this zigzag here. Either will work. And then the hydroxyl needs to be on the 2 position, so 1, 2. And you could also count from the right hand side as well. And then this is our 2 carbon, and there has to be a methyl on the 2 and the 3. So here's our methyl on the 2, and here's our methyl on the 3. Now, is this a primary, secondary, or tertiary? It's actually easier to see it in this structure here, and we can see that this is a tertiary alcohol because this carbon that's bonded to the hydroxyl is bonded to 3 other carbons. And actually I said it was easier there, but if we looked at the line structure, here's our carbon bonded to the hydroxyl, and it is bonded to 3 other carbons. So it is tertiary. All right, now let's look at our cyclopentanol, and of course our hydroxyl is going to be on the 1 position and the ethyl will be on the 3. And it doesn't matter if you put it on the left or the right. Here they chose to put it on the right, and if you did the line structure, then this ethyl group would just be kind of a V, if you will, that would have 2 carbons. All right, so if you got those right, give yourself a pat on the back. Oh, I forgot to identify this as a secondary alcohol. This carbon here has 3 bonds that are distinctly drawn in the line structure. 2 of them are to other carbons and the other one's to a hydrogen, so it's secondary. So if you got all of that right, give yourself a pat on the back.